Hello, Math 120, and this is Professor Gonzalez, and I'd like to take a look at some homework problems from 5.1. Now, 5.1 sort of changes up a little bit, and we're taking a look at rational expressions, not equations, but rational expressions, and how to simplify the rational expressions, and those kind of things. Rational expressions are just fractions, but they're fractions of polynomials. The rules of fractions still apply for polynomials. So for instance, if I had something like 2 times 3 over, let's say, oh man, let's see what I want to do here. Okay, let me start over again. If I had a fraction that was 2 over, let's say, 2 times 3 in the denominator, right? So really that fraction, what was that fraction? That fraction would have been 2/6. You know, you're so used to reducing, you probably don't even really kind of think about what you're doing. But what you're doing is you're reducing common factors. So common factors are allowed to reduce down, right? 2 divided by 2 is 1. And so that leaves us with a 1 over 3. That's great. But what do people do when they start having polynomials? They forget these basic rules and they start doing some crazy things. So let me show you that crazy thing that they would do. If you did this crazy thing in arithmetic, I think you would know it's not right. If I said 2 over 2 plus 3, well, we know that that actually equals 2 over 5, right? 2 plus 3 is 5. But what students would want to do in the polynomial world of these rational expressions is they want to, whoops, darn it, I just changed. That was a 2 there. What they want to do is they feel like they need to reduce common terms. You're not allowed to reduce common terms. You can only reduce common factors. So this would actually produce a 1/3, and we know the answer is 2/5. So this doesn't work. And that's kind of what this question is getting at, is notice what this person did. They saw x squared and x squared, and they were just too enticed. They could not resist themselves, and they figured that they can reduce x squared over x squared, leaving us with 3x plus 5 over 7. And this would be an example of this guy over here of reducing terms, which is highly illegal. Illegal cancellation, right? Not allowed to cancel those or reduce that. So the answer here is this is false. And why is it false? False because when simplifying x squared, x squared cannot be divided out from the numerator and the denominator. Meaning you can't factor it out and turn it into a factor and then cancel common factors. Okay, let's move on to the next one. This is a big thing. It really is a big thing because you'll find that after you do a bunch of work, you might have this kind of moment of weakness where you have something like 3x plus 5 over let's say 3x, and that looks so tempting to do some reducing, but you can't because these are terms. 3x is a term and 5 is a term. Now if that was a multiplication symbol, then those wouldn't be terms, that would be factors, and factors are allowed to be reduced. So it is something you got to be real careful with. Okay, moving on, it says number 2, the denominator of the rational expression is, it doesn't say that. The denominator is x plus 4. What it says here is, I don't know what I was looking at. It says determine the domain of the rational expression. Okay, so the domain basically is all the x values that are eligible to be used in this rational expression. What x's can we use? And that might sound kind of strange. It's probably better to say what x's are we not allowed to use. What do you mean? Well, remember that we're never ever allowed to divide by 0, right? Any kind of fraction with a 0 in the denominator would be considered undefined. So really what we're saying is we can figure out the domain, which is all the x values that will be used in this problem that are legal to be used, except for the ones that cause this to be undefined. So basically, we're looking for what makes the denominator equal to 0. And you may have guessed it. Well, you don't have to guess it, right? All we have to do is subtract 4 on both sides, and we get x equals -4. So really what I probably should say is the denominator x plus 4 can never equal 0, because if equals 0, you're dividing by 0, it's undefined. So we can use any value of x except for -4. So here's a way to say it. The domain is the set of all x's such that x cannot equal -4. Boy, throat's a little raspy right now. And I'm just starting. That's not good. Maybe a little glass of water. Ooh, I only have a drip left. Number 3. So number 3 is the same idea, that this denominator better not equal 0. So we need to factor this. When we factor this problem, we're asking what multiplies to -36 and adds to -5. Also remembering that this is considered easy, right? Because that leading coefficient's 1. So we look for some numbers and we come up with -9 times 4 is -36 and -9 plus 4 is -5. So it turns out that this factors down to x minus 9 times x plus 4. And this better not equal 0, because that is in the denominator. We better not get a 0. So we're solving this quadratic equation, this trinomial, because whatever solves that trinomial will make that denominator 0. So remember the zero factor property that we looked at? Well, we set x minus 9 equal to 0, and x cannot equal, add 9 to both sides of 9. And we set this factor equal to 0, x plus 4 equals 0. And by the way, we're saying not equal to 0, right? So subtract 4 on both sides, and x cannot equal -4. So the domain is the set of all x's such that x cannot equal 9 or -4. Simplify the rational expression. So just like I was showing how to simplify this, here's where I did it legally, right? That's what we want to do. And how do you simplify a fraction or a rational expression? You factor it and then look for common factors to reduce. So we're going to take this and we're going to need to factor the numerator. So I can factor out a greatest common factor of 6. That gives me x plus 3. The denominator, remember this denominator is something special, right? This is a perfect square minus a perfect square. So that will factor down to x plus 3 times x minus 3. And then what we do is we cancel common factors. So this is multiplied here. So this whole chunk is a factor. And if I have an identical chunk, which I do, they reduce. This leaves me with an answer of 6 over x minus 3. Okay, flip the page to the next page, and this is number 5. Number 5 is asking us to simplify. So once again, what we need to do is we need to factor completely. So down below, p plus 3 is factored completely. You don't have to, but I'm going to put parentheses around it showing that that's prime and factored completely. If I could find an exact copy of the quantity p plus 3 up top, I get to reduce it as long as they're factors. So once again, realizing that that's an easy factoring problem because it is a 1. It doesn't have to be red, by the way. But there's a 1 in the leading coefficient. This is going to be fairly easy. What multiplies to 12 and adds to 7? And I believe that's going to be 3 times 4 is 12, and 3 plus 4 is 7. So this will factor down to p plus 3 times the quantity p plus 4. So we want to go ahead and reduce common factors of p plus 3. Now that p plus 4 is in the numerator, so we don't need to show a fraction anymore, right? It's just p plus 4. Next problem. Okay, once again, we're going to need to factor. So I see a common factor here of 9. Factor out the 9. Leaves me with x minus 3. I see a common factor of x squared, which leaves me with x minus 3. X minus 3 is a factor, right? This is being multiplied. So that whole factor reduces, leaving me with a final answer of 9 over x squared. Next problem, number 7. There's enough space there. Yeah, I think so. So these problems are getting a little more complicated, but the factoring still is not too bad. Once again, realizing that both of these quadratics or trinomials have a 1 in front of it, so that will make it a little bit easier if they're factorable. So let's take a look at this. Let's do the numerator right down here. So what are we looking for? We're looking for two numbers that multiply to 56 and we'll add to 15. What multiplies to 56 and adds to 15? How about 7 times 8 is 56 and 7 plus 8 is 15. So this would just reduce, or not reduce, factor down to q plus 7 times the quantity q plus 8. And then we take a look at the denominator here. Let's work that right here. We say what multiplies to 16 and adds to 10? Well, what multiplies to 16? How about 8 times 2 is 16 and 8 plus 2 is 10. So this will factor down to q plus 8 times the quantity q plus 2. Now you can see there are some common factors, and once again you know they're factors because they're being multiplied. Q plus 8 cancels or reduces with q plus 8, leaving me with my answer of q plus 7 over q plus 2. Q plus 7 over q plus 2. The next problem is number 8, but I did number 8 down here because I needed more space. So let's flip on down here to number 8. So number 8 is going to need more space pretty much because look at that. It's not the easy type, right? It's not quite as easy because it doesn't have a leading coefficient of a 1. So this, because of that, it just requires more space and work. So what we're going to do is, let's go like this. We know it's going to factor. Hopefully you know it's going to factor. We don't know for sure, but we're going to try. So I'm going to take this. I'm going to start working these problems over here. So how much space am I going to have here? So the problem, so let me go like this. The problem is 3. Yeah, I guess I can do that. The problem is 3y squared plus 22y plus 24. Now remember, in order to do this, I'm going to need to multiply 3 times 24 to get that number right there. So 3 times 24. 3 times 24 gives me what, 72. Get rid of that. Oops. 72. Okay, and then it needs to add to 22 right here, right? So you search and search, and you can do some work down here to look for that. You really want to look at factors of 72. So, 1 times 72, 2 times 36, 3 times 24, 4 times 18. Oh, 4 times 18. Sounding pretty good because 4 times 18 is 72, and 4 plus 18 will give me 22. So we know now that by doing a bunch of these problems before, these are sort of like our target. Whoops, that's really big. Those are basically our target numbers that are going to, whoops, which are going to replace this number right here. So, of course, I already have this 3y squared. Replace 22y with plus 4y plus 18y, and this yellow plus 24. We take a look at the first two. Now we factor by grouping. 3y factors out, leaving us with y plus 4. Now for grouping to work on the next two, we have to have a group of y plus 4. So I'm going to write that down and then check and see if I can make that happen. I'm going to factor out an 18. And let's see, 18. No, something's wrong here. Let's see. 4 times 18. Something went wrong somewhere. Oh, geez. What the heck did I do? Oh, there it is. Okay. Better start concentrating a little bit here. Let me just get rid of this whole line and start again. I need to factor out a common factor, which is just y. Right? When I take a look at this, not 3, because, 3 doesn't go into 4. So we factor out a y, and we're left with 3y plus 4. So 3y plus 4 is the group I'm looking for, and can I make that happen? How about if I say plus 6? So distribute your 6 times 3y and you get 18y. And 6 times a negative 4 is, 6 times 4 rather, is positive 24. So that's looking good. And so what factors out is our common group, which is 3y plus 4 times what's left, which is y plus 6. So that is the numerator. Y plus 4 times y plus 6. Okay, now let's go ahead and do this denominator. It's going to have some similar feel to it in the way that it's not of the easy type, right? We need to, so let me write this down. This one's going to be 3, what am I at? 3y squared. Wow, how did I do that? That's so weird. I wrote that top down, and then I wrote, I think I better take a break before I really mess up every single one of these. All I'm doing is just copying things in a weird way. So let me just rearrange my arrows. Somehow I copied this one down. 3y squared plus 22y plus 24, and I did that there. Which means I need to copy this one down and sneak it over here and do it right there. Interesting. Okay, so now apparently, wow, so the answer to this was the denominator. So this work over here was the denominator, which came out to be this guy right here, which was 3y plus 4 times the quantity y plus 6. Now, I'm doing the numerator. Didn't mean to do it that way, but the numerator is now 3y squared minus 11y minus 20. I'm looking for two numbers, so I need to multiply to 3 times negative 20. So if I multiply to 3 times negative 20, I get negative 60. What two numbers multiply to negative 60 and add to this negative 11? That's going to be negative 15 times 4 is negative 16. Negative 15 plus 4 is negative 11. We're going to use those two numbers. I'll go ahead and show that these two numbers are going to replace that guy right there. So I've got the 3y squared, and then I'm going to replace the blue with the blue, so negative 15y plus 4y, and then write down this yellow minus 20. Now we're going to group. Looks like 3y is in common, so what do you have left is y minus 5. So we're going to have to create another y minus 5 in order for this grouping to actually work. And I believe if I factor out a 4, let's see, 4 times y is 4y, and 4 times negative 5 is negative 20. So that worked perfectly. So we factor out this orange y minus 5, and we're left with the black 3y plus 4. So that was our work from our numerator. And so let me write that up here. Y minus 5 times 3y plus 4. Okay, and now we're hoping, are there any common factors? And so take a look, and it looks like we have a 3y plus 4 up top and a 3y plus 4 on the bottom. And we're left with the remaining factors, which will be the answer to our problem. That is, this would simplify, right? Simplify the rational expression, which is just a fraction on steroids, basically, to y minus 5 over y plus 6. Those were the remaining factors. Y minus 5 over y plus 6. Okay, great. Let's get on back over here. Let's do number 9. Now, number 9 is in this form where, you know, we like to have it in the standard form where you have the highest power first and having that leading coefficient be a positive number. And when we have that form, it's not super essential, but it just helps us line up common factors when we're factoring, kind of keeping things in a really organized format. So really probably the first thing you're going to do here is factor out a negative, which is now going to make this k squared minus 81. If you distribute that negative, you'll find out you have this right here. We still have this, and we're going to have to do some factoring. And so up top, you're going to notice that this is a very special perfect square, k, right? Minus another special 9 squared, which is a perfect square. So that just factors down to k plus 9 times k minus 9. Down below, once again, we've got our easier type of factoring problem with the 1 right there. So the question is, what multiplies to a negative 72 and will add to negative 1? What multiplies to a negative 72 and adds to negative 1? How about a negative 9 and a positive 8? So this will factor down to k minus 9 times k plus 8. And now you can see that we have some common factors. K minus 9, and then that's it in terms of reducing. What do you have left? Now don't forget your negative sign, and usually we put the negative sign out here. If you keep the negative sign up top, that would be correct as well. I did not check. I think I checked last set of problems, if my lab would accept it that way, and I believe it did. But this is a negative out front, so now we have just a negative out front and k plus 9. The denominator would be k plus 8. Just to be clear, if you left the negative up in the numerator, you would have to keep parentheses or distribute it, either way. So it's probably easiest just to put the negative out in front. Let's take a look at the next one, number 10. And of course, we're going to need to simplify this as well and factor out the greatest common factors, your best bet at first. Looks like there's a common x, which leaves me with x squared minus 4x minus 12. And the beautiful thing about that is that, what? Is that now this is at least a 1 there, which would make it easier to factor. Whoops. So let's continue with this, I guess. See if we can factor that numerator. We already factored out a greatest common factor of x. So what multiplies to negative 12 and adds to negative 4? What multiplies to negative 12 and adds to negative 4? Anybody have something there? How about x minus 6 times x plus 2? Multiplies to negative 12 and adds to negative 4. Yeah, looks good. Down below, I'm going to factor out a greatest common factor of 3x squared. And when I do that, that leaves me with x squared minus 4. Turns out, so that 3x squared factored out, turns out that this is a nice, beautiful difference of two perfect squares, which means it's going to factor further to x plus 2 times x minus 2. Now we have this polynomial written as prime factors, and so if we see any common factors, we have to, or we want to, reduce them in the numerator denominator, right? So I see x plus 2 and x plus 2. I also see that a common x will reduce with one of these x's, leaving one still. And so what do we have remaining? I'm seeing an x minus 6 up top. I'm seeing, don't forget your 3x below times the quantity x minus 2. So we have x minus 6 up top, down below 3x times the quantity x minus 2. And notice people will get creative and they'll want to reduce like 3 and a 6 or a 2 and a 6. But this is a prime factor, and the only way you could reduce that x and the 6 is if you have an x minus 6 as a group. So that is done. Now we're going to take a look at number 13, is that right? It's number 8. Uh-oh, am I missing something on this? 13, 14, yikes, 15, a whole bunch of problems got erased somehow. Okay, so then we take a look at problem number 11. Problem number 11 is a special product. If you take a look at this x, if you take a look at this, x is a perfect cube, and 27 is also a perfect cube, 3 cubed. So we have the sum of two perfect cubes. So just like we had before, remember that sum of perfect cubes has a formula that just needs to be memorized. That's going to be x plus 3 times the quantity x squared minus 3x plus 9. Then the denominator, luckily, is considered an easier factoring problem, right? And so we're just looking for two numbers that would multiply to negative 27 and add to negative 6. Negative 27, negative 6. How about negative 9 times 3? So if you have negative 9 times 3, that means that this will factor down to x minus 9 times x plus 3. Now we're fairly happy because we see common factors of x plus 3 being reduced, leaving us with the final answer of x squared minus 3x plus 9. Now this numerator up here is prime, right? You can't factor it down any further. And the denominator is x minus 9. It may be tempting to try to reduce the 9's, but remember, they're terms, they're not factors, so don't do it because you'll be wrong then. You might feel like this must be factored. Just to let you know, as long as you factor out the greatest common factor when you're starting these kind of sum of two cubes, as long as you factor out the greatest common factor before you start, then this is going to be prime. But you could also convince yourself that it's prime by saying, what multiplies to 9 and adds to negative 3? And you'd say, well, 1 times 9, 3 times 3, is there any way I could add two negative numbers together to get a negative 3, and there really isn't. So this is the finished answer of reducing that down. So simplifying the following rational expression. Let's take a look at the next one here, and multiply. Okay, so we're changing it up a little bit right now. Now what we're gonna do is we're gonna multiply, and multiplying is just simplifying, really, because notice multiplying is just creating another factor. Really, is all we're doing. We're just creating more factors, and so if we have common factors in the numerator or denominator, we get to reduce them. So let's write this a little bigger so it's easier to see. And up top now we just have 7 times x times the quantity x minus 3. Don't distribute it because then they're all going to be terms and you can't reduce them. Let's take a look at this. Now this is a monomial, so I'm going to chuck that at the beginning, 21x squared. Right? These are being multiplied, so they are considered factors, right? Next of all, we need to factor that. What multiplies to a negative 21 and adds to 4? What multiplies to a negative 21 and adds to 4? How about x plus 7? Whoops, sorry. That's not going to be negative. How about x minus 7 times x plus 3? You can see a set negative 7 and 3. No, wait a minute. What's going on here? That's not right. What multiplies to, where am I at? It should be positive 7 and negative 3. Not sure what I'm looking at here. Anyways, positive 7, negative 3. Since I kind of botched that a little bit, let's make sure you're seeing what I'm seeing now. X squared plus 4x minus 21. Remember, we're looking for two numbers that multiply to negative 21 and adds to 4. And so if I'm going to add to a positive 4, this must be a positive 7 and a negative 3 to add to 4 and multiply to negative 21. Now let's go ahead and see, do we have any common factors? And x minus 3 and x minus 3 are common. And so are, let's use another color, so are the x's. So there's one x that cancels or reduces one x, leaving an x down below. And also, let's get another color. How about 7 will cancel? So there's a common 7 that will cancel or reduce out, leaving a 3. Okay, now what do we have left as our final answer? Don't think I'm going to be able to fit it right there. So we have our final answer as, well, everything reduced down to 1. So we've got a 1 up top. Down below, don't forget the 3, don't forget the x, and we have the factor, the binomial of x plus 7. So there it is, 1 over 3x times the quantity x plus 7. And moving on to number 13. Now these are getting a little bit tougher to deal with because, look at, we got 4 polynomials that must be factored, and a couple of them are harder factoring problems. So these do get a little more challenging in some ways. So let's see if I can fit all of this. I think I'm going to zoom in just a little bit. And I think the difficult one to deal with, just trying to think of space. Can I refer back up here? Yeah, I got space up there. That's an idea. Okay, so how about if I take this one and try to deal with it up here? So this is 3x squared minus 4x minus 4. So remember that this would be considered not as easy because of that 3 right there, right? So we must multiply 3 times negative 4, which will give us a negative 12. So the question is, what two numbers multiply to negative 12 and adds to that negative 4? Right? What two numbers multiply to negative 12 and will add to the 4? And what do we get? Negative 6 and positive 2. Okay, so now we're going to take those two numbers And why are we going through all this extra work? Well, because we have to, because of that 3 right there, right? That's causing us to have to go do all of this extra stuff. We're going to replace the blue negative 6 and 2 with the negative 4x. So we're now going to have negative 6x plus 2x minus 4. Now we got to factor by grouping, and I see a common 3x that we'll factor out. What's left after I do that? What's left is an x minus 2. Now we better get x minus 2 here, so we try to see if we can. And what times x will give us this grouping? Well, how about 2 times x gives us 2x, and 2 times negative 2 gives us negative 4. So that looks great. We can factor out the common x minus 2. What do we have left? 3x plus 2. So, what a mess, but let's go ahead and write down that we just figured out the numerator, which is x minus 2, 3x plus 2. I say what a mess, that wouldn't be too bad, but we've got more to go, right? We've got more to go. So let's deal with this one now. And, you could write this all in the same numerator, or you can say times, put a multiplication symbol, and go like that. But the fact is that all of these are going to be factors, right? They're all going to be factors. So any factor in the numerator is eligible to be reduced with factors in the denominator. So in essence, you can write this as one big fraction then. So let's take a look. What's going on with this guy? So let's put a little barrier right there to show that we're walling that off. And we're going to do this work right up here. So this one is x squared minus 6x minus 24. And once again, we're pretty happy to see that there is a leading coefficient of 1, which means we don't have to do all of this extra grouping business over here. All we have to do is find the right combination of what multiplies to negative 24 will add to negative 6. Okay. So I'm going to let you think about that for a second. What multiplies to negative 24 and adds to, and we don't have, let's see, on this particular one, okay, I see that I copied that down incorrectly, just having a field day with errors. So these copying errors, this is x squared minus 6x minus 72. So that is a 72 right there. So I've got to change that, modify that right there. And we're saying what multiplies to negative 72 and will add to negative 6. What multiplies to negative 72 and adds to negative 6. And that's going to be a negative 12 times a positive 6. So then what happens here, let's just make sure I copied everything down right, x squared minus 6x minus 72. Okay, good. So then this factors down to x minus 12 times the quantity x plus 6. So now we have this numerator right here of x plus, or x minus 12 times x plus 6. Let's do the denominator. Maybe I go down a little bit further than that because I'm going to have to put an answer. Okay, so what's going on here, right, is x squared plus 5x minus 6. So the question is, let's see if we can do this in our head. What multiplies to negative 6 and adds to 5? What multiplies to negative 6 and adds to 5? How about an x plus 6 times x minus 1? Double check it. 6 times negative 1 is negative 6, and 6 plus a negative 1 is positive 5. So that did work. So now we have an x plus 6 times the quantity x minus 1. And we're just down to one more problem to factor, and that is this guy right here. And we'll go ahead and show our work, I think, over here. So this problem is 3x squared. Got to make sure I copy it down right this time. 34. So 3x squared minus 34x minus 24. And once again, we're not super happy because we've got that 3. But we do have ways of dealing with it. We multiply 3 times negative 24. And what is 3 times negative 24? 3 times negative 24 is going to give us, I think I'll go up here because of space. It's going to give us a negative 72. So what multiplies to negative 72 and adds to negative 34? And that's going to be negative 36 times 2 gives us negative 72. And negative 36 plus 2 is negative 34. So remember now what we want to do is we want to replace my two target numbers with that middle number. That's just going to give us minus 36x plus 2x minus the yellow 24. Now we're back to the good old grouping, which is just 3x. What do we have left when we factor out 3x is x minus, was that it? 3x? Yeah, x minus 12. X minus 12. So x minus 12 is the grouping we're looking for. And let's see if that can happen over here with the next group. And if I factored out a 2, let's double check. 2 times x is 2x, and 2 times negative 12 is negative 24. So it worked beautifully. So our common x minus 12's factor out, leaving us with 3x plus 2. So that's what that just factored down to. X minus 12 times the quantity 3x plus 2. And this was the nightmare problem, right? Now, hopefully some things will reduce. Okay, let's see. I'm going to use red first of all. And I see that I've got a common 3x plus 2 and a 3x plus 2. Awesome. Anything else? Anything else? How about an x plus 6 and an x plus 6? Anything else? And how about an x minus 12 and an x minus 12? And I think that is it. What is remaining? Well, up top I see x minus 2, and down below I see x minus 1. You did all that great work, and you got it right. What you don't want to do is think you can reduce the x's, right? They are not factors, they're terms. So you have to leave it as x minus 2 over x minus 1, and you're done. That was a challenging one. That is the most challenging one I believe that we've got. Let's move on to number 14. In 14, we're going to have to do some more factoring, of course. It says multiply and simplify, and it's a little bit deceiving. Because if you decided to multiply all this out, as you know the process, that would give us a polynomial that would be such a monster we probably couldn't even factor it to reduce. So that would be a bad idea. So it says multiply and simplify. Really, factor and simplify is what's going to happen here. So let's take a look at that. Okay, let's go ahead and get our factoring going. And I see something special here. I see that up top here I've got a perfect square minus 4 is a perfect square. 2, right? 2 squared is a perfect square. So this guy right here will just simply factor down to x plus 2 times the quantity x minus 2. Right? And down below here, I see this as a perfect square also, right? 4 squared is 16. So a difference of 2 perfect squares again. So that's just going to factor down to x plus 4 times the quantity x minus 4. Now what about this guy right here? That is x squared minus 2x minus 8. What two numbers multiply to negative 8 and will add to negative 2? Well, I'm thinking how about negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. So this just factors down to x minus 4 times x plus 2. And then finally, this guy right here, we're also fairly happy about that, right? Because of that leading coefficient, once again, is just a 1, just like the last one. So it's just x squared plus 5x minus 14, which means it's of the easier type. What multiplies to negative 14 and will add to 5. If we're going to multiply to a negative, we've got to have a negative times a positive. And I'm thinking, how about a positive 7 times a negative 2 gives me negative 14 and also adds to positive 5. So therefore, this polynomial factors down to x minus 2 times the quantity x plus 7. So that's going to go right here, x minus 2 times the quantity x plus 7. Now, this is the fun part. Where can we reduce? And I see an x minus 2 and x minus 2. I hope there's more than that, huh? Oh, there we go. There's another one. Be kind of unsatisfying. X minus 4 and x minus 4. And I think that is it. That leaves us with an x plus 2, two of them, so squared, over x plus 4 in the denominator times the quantity x plus 7. So x, quantity x plus 2 squared, all over x plus 4 times quantity x plus 7. Right. Let's keep her going here. Number 15. And number 15, looks like we've got some possibly challenging factoring to do here. So this is going to take a little bit of time also. Okay, so let's buckle up and go for it here. That was kind of dumb. Anyways, so let's take a look at this right here. This is going to, I think what I want to do is I want to put this up here and work the problem, because I've got a lot of space to do that with. Oops, why did that freeze on me? So that was 6q minus 41q minus 7. 6q squared minus 41q minus 7. So what do we need to do here? Well, because it's not considered an easy factoring problem because of that 6, we better multiply. And I think I'm going to go up here to do that. 6 times negative 7 is negative 42. What multiplies to negative 42 and adds to negative 41? Well, that's going to be a negative 40. The nice thing is this is not that hard. Well, I mean, as long as you remember 42 times 1 is 42, but negative 42 times 1 is negative 42. And when you add negative 42 and positive 1, you get negative 41. So that would be the combination that we're looking for, but because it wasn't of the easy type, we got to, don't forget our extra step on this one, and that is we need to group. So 6q squared minus 42q plus 1q minus 7. Now let's go ahead and group. 6q, well then factor down to 9. I guess I should use my color. I don't know if I need to for sure, but I'm going to do it. Creature of habit here. So this is q minus 7. We factored out. Now I need a matching q minus 7. So what can factor out of the next binomial is a positive 1 times q is q, and positive 1 times the negative 7 is negative 7. So we have our grouping, which is common, which factors out. And what's left is 6q plus 1. So now we just found out that the numerator is just q minus 7 times the quantity 6q plus 1. That's our first quadratic, all that, right? So we got what do we have? We have q minus 7 times the quantity 6q plus 1. Let's do this next one right here, since I've got this space up here. So I'm going to put this right up here. So that is 5q squared plus 46q plus 9. Double check, 5q squared plus 46q plus 9. Once again, unfortunately, this is not of the easy type because of that 5. That 5 is causing us some headache. But what we could do is multiply 5 times 9, which will give us this pattern that we're looking for. 5 times 9 is 45. So what multiplies to 45 and adds to 46? And I see something similar to the last one, right? 45 times 1 is 45, and 45 plus 1 is 46. So we're going to replace these target numbers with that middle number in our trinomial, and we get plus 45q plus 1q plus 9. We go to group, we factor out a 5q. By the way, I needed to copy the square, didn't I? 5q squared. Okay, so now when I factor out my 5q, what do I have left? I have just q plus 9. I need a q plus 9 for the grouping to work. And I'm pretty sure I can make it because all I have to do is 1 times q is q and 1 times 9 is 9. So that did work beautifully. And factor out my common factor, q plus 9. What is left is the stuff in black, which is just 5q plus 1. Awesome, let's write that down. That was this numerator factored down to q plus 9 times the quantity 5q plus 1. Look at the denominator right here. So we're going to go ahead and bring this down here and work the problem. 5q squared plus 31q plus 6. Once again, not too happy. I'm not very happy in this problem because that is a 5 is not as easy. So that's okay. We can deal. We multiply 5 times 6, which is going to give us 30. We're looking for two numbers that multiply to 30 and add to 31. Gee, I think I see a pattern going on in this problem. At least the factoring is not too bad, right? 30 times 1 is 30, and 30 plus 1 is 31. So our two target numbers are just going to be 30 and 1, which makes 31. So we do the replacing. 5q squared plus 30q plus 1q plus 6. Factor by grouping, and I'm going to factor out a 5. Wow, I don't have a lot of space there, but remember my little trick I learned from before? I could actually just move that out of the way. Technology is amazing. So 5q, no, look at, but it always makes me mad, so no, it's not amazing. 5q squared, and remember, I've got, I got to remember what I'm doing, because I got into my little technology trick. Factor out the greatest common factor with just that binomial, and that is 5q. So what do I have left? I've got a q plus 6. I need the factor or the grouping to be q plus 6. Can I make that happen with the remaining binomial? Yes. 1 times q plus 6 is q plus 6. So we factor out the greatest common factor, which is the grouping part, q plus 6. What do you have left? The stuff in black, which is just 5q plus 1. Okay, so we got our 5q, or so q plus 6 times 5q plus 1. That's that guy. Okay, we're down to just this right here. This is the remaining little bit that needs to be dealt with. And it really is prime, but remember, we like to have our first powers first are constant second, and when you do that, when you reorder that, it's going to be negative q plus 7, and we don't like to have that negative in front. So all we're going to do is factor out the negative. So if you factor out a negative, that gives us a negative times q minus 7, and we know that's correct because if I say a negative 1 times q, I get a negative q, or even look there, minus q. And if I take a negative 1 times a negative 7, I get my positive 7, or positive 7. Okay, and the only reason why we really do that is because it lines up, it puts the q's first and the constant second, and it makes it easier for us to find our common factors. So what we're going to do is we're going to go ahead and look to reduce common factors. And I'm looking around and I see a q minus 7 up top and a q minus 7 down below. And you might have missed that if you didn't factor that negative out. And let's see, do we have more? I hope. How about 5q plus 1 and 5q plus 1? Question, anything else? And I'm not seeing anything else. So let's write our final answer. Now, what you got to do is you got to remember this negative. And technically, the negative can go up top or on the bottom. Probably best to just put the negative out in front. Okay, so up top we have 6q plus 1. That's this guy right here. We also have a q plus 9. That's that guy right there, q plus 9. Then down below I have the negative dealt with, and I've got a q plus 6. Now that was, I think, the toughest one. So our answer is negative, and then the quantity up top, 6q plus 1 times the quantity q plus 9, all over q plus 6. Awesome. Since this isn't being multiplied by anything else in the denominator, you don't need the parentheses, but you could also use them if you want. Let's take a look at number 16, and we're changing what we're planning to do here. We're now dividing. We're dividing the rational. Now, how do you divide fractions? Remember that from arithmetic? If someone said 2/3 divided by, they might write it like that, right? But you could also write divided by as a big fraction. 2/3 divided by, let's say, I don't know, 1/6. How do you do it? Well, you take 2/3 and you multiply it by the reciprocal of this denominator, 6/1. And then you reduce if you can reduce. Well, I'm seeing some reducing. Right? Technically, if I want to treat this problem like what we were just doing, right, you'd factor 6 down to 2 times 3. Now they're factors, right? And those are prime factors. And then you just look for prime factors to reduce with. And I see a 3 and a 3. And there you go. I don't know why I felt like I needed to do that whole problem. That's going to be 2 times 2 up top is 4 with a 1 on the bottom, so that's just 4. Good to know, huh? Okay, so now remember, how do you actually simplify rational expressions? Same thing. Same thing. We take 9t over s squared and multiply it by the reciprocal of the denominator. That would be s over 3t squared. I flipped it, right? Reciprocal. So now what we need to do is we need to reduce. And you can just reduce it as it is. If we wanted to do it like we've been doing it, which is not really necessary when the problem is not as complicated. Let's see, just making sure I wrote down problems correctly, just double checking. Okay, so what you could do if you really wanted to factor it down more, I don't think you would have to do this, but you can write 9 as 3 times 3. Now these are definitely, and then t is just t. So these are definitely now primes, right? And then s down below is s times s. Like I said, I don't think you need to go to this detail. I think you do it without factoring it completely like this. And then t is t times t. But I guess I'm trying to show that it is similar to when you have binomials. It's just these are little single single monomials. So let's go ahead and reduce where we can. I'm going to see that I've got a common, whoops, what happened there? Something weird happened there. Okay, I've got a common S that will reduce. We also have, that color's not going to work. We also have a common T that will reduce. And even we have a common 3. I think I got them all. Let's see what we have left. And if you didn't get it all, you can take a second whack at it and fix it. But I see that there is a 3 up top, and then down below is ST. So 3 over ST, and that's correct. Okay, we only have 2 more to go, and we're done. Let's see, number 17. Number 17, once again, is the same type of problem. We're dividing the rational expression. How do you divide rational expressions? Well, you multiply by the reciprocal, which is flipping it, right? So let's give ourselves a setup here. And I gave myself lots of space because I could see this could take some space. So look at the numerator, and that's just going to be p squared minus p minus 12 over 2p squared minus p minus 1 multiplied by its reciprocal. It's reciprocal of the denominator. So there's the numerator now, p squared plus p minus 2. And now there's your denominator, p squared plus 3p. So now we need a factor so we can reduce. Let's do this. So what multiplies to a negative, what multiplies to a negative 12 and adds to negative 1? Maybe p minus 4 times p plus 3. Negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. Perfect. How about this one? What multiplies to a negative 2 and adds to positive 1? What multiplies to negative 2 and adds to positive 1? How about p plus 2 times p minus 1? Let's see. 2 times negative 1 is negative 2, and 2 plus a negative 1 is positive 1. Perfect. Let's take a look at the bottom denominator. It looks like there's a common p that gets factored out. So we're left with p plus 3. Done. Now we're just left with this guy, which is a little bit tougher because it leading coefficient's a 2, but still those numbers are pretty small and I think are going to be pretty easy to deal with. So once again, we look at that. We know we have to multiply 2 times 1. 2 times 1 is negative 2, and it must add to negative 1. So that's just going to be what? A negative 2 times 1. So we write down 2p squared. We replace, once again, these target numbers with this middle, negative 1p. So this is going to be negative 2p plus 1p minus 1. Factor out the greatest common factor of 2p, which leaves us with a p minus 1. We have a p minus 1 here, so we just factor out a 1. Factor out the common factor, which is p minus 1 times the quantity 2p plus 1. So that factored out pretty quickly to p minus 1 times the quantity 2p plus 1. Now cancel common factors. And this is the fun part, as I say. P minus 1 and p minus 1. Anything else? How about, let's change the color to red. P plus 3, p plus 3. And I think that is it. I'll take a closer look here. And up top we're going to get p minus 4 times p plus 2. Down below we get, don't forget the p there, we get p times 2p plus 1. So it's p minus 4 times the quantity p plus 2 all over p times the quantity 2p plus 1. There it is. Last problem, 18. Once again, we have a fraction divided by another fraction, so you know what to do. You take x cubed minus 27 over x squared minus 9, and you multiply that by the reciprocal. So this goes in the numerator, x squared plus 7x plus 1. And this is now my denominator of 2x squared plus 6x plus 18. 2x squared plus 6x plus 18. Okay, so it's really going to pay off if you remember some special products, meaning that this is a perfect cube minus this is a perfect cube. This is the difference of two perfect cubes, which will just factor down to x minus 3 times x squared plus 3x plus 9. Pretty much has to be memorized. Now this is a difference of a perfect square minus a perfect square, a difference of two perfect squares. That's x plus 3 times x minus 3. I do see that I can factor out a greatest common factor here. Let me go ahead and do that first to see if that goes anywhere. So I can factor out a 2, which leaves me with x squared plus 3x plus 9. If I factor out a 2, I get x squared plus 3x plus 9. Now, what happens with this? Do I have any numbers that multiply to 9 and add to 3? 1 times 9 and 3 times 3. Let's see how they're going to add to 3. So this actually is prime and is done. So we have 2 times the quantity x squared plus 3x plus 9. And that feels kind of unsettling because it feels like that should factor, but it happens to be prime. And I get it. When that happens, you start looking around to see, did I make a mistake? Now the last thing we got to do is we've got to try to factor this one. And we like the fact that there is a red 1 in front of it. So we're going to ask the simple question, what two numbers multiply to 1 and adds to 7? Wait a minute. The possibilities to multiply to 1 is just 1 times 1, and there's no way a 1 and a 1 are going to add or subtract to 7. So that's also prime. So that is it. The only way I can reduce that, x squared plus 7x plus 1, is if I have an exact copy of that trinomial down below. So now it's time to reduce common factors. And so we'll use the red. And ooh, look at that. I have exact copy of x squared plus 3x plus 9 right there, and x squared plus 3x plus 9 there, and really realizing that all of these are being multiplied, so these are truly factors, and that's where we're allowed to do that. Anything else would be beautiful. Let's see, how about x minus 3 and x minus 3? And I think that's it. Be careful not to leave any factors on the table there. Up top I see an x squared plus 7x plus 1, yeah, right there. Down below I see a 2, that's going to be easy to forget, but don't do it. 2 times the quantity, and then we've got our x plus 3. There it is. X squared plus 7x plus 1 all over 2 times the quantity x plus 3. And that is it. I hope you have a great one. Take care. Bye.